so this is going to be double displacement. Some people call it, look up in the book, what do they even use for this in this book? Some books use displacement, some books use displacement. Okay.
What chapter are we on? 9?
Yeah.
I don't know. I think I don't know. 9 was nomenclature. I don't know what we're on. I have no idea what we're on. It's in there somewhere. It's like 9, 10, 11, or 12, one of those. Anyway, just look up in the back. Look up look up double replacement, or just look up double. It'll be under double. Okay. So there are 3 types. It's double. What does it say? Okay, we don't know yet. We don't have an answer on that. That's not a problem. Okay. So double. They're looking up feverishly. Okay. Excellent. My minions. You know, you've seen. Despicable Me. Yes, I'm despicable, as you know, and I have minions. Okay, I have minions. Double replacement, they say? Double replacement. Some they call it double displacement, and there's reasons for that. Okay. So there's 3 types of double replacement reactions. Now, the point of this is going to be this. This is the point. I'm going to give you the names. I'm going to do an example full out, and then I'm just simply going to tell you each type. But the first one I'm going to do is I'm going to do it from beginning to end, where I'm going to give you the product. I'm going to give you the reactants. Then you have to A, predict the products, and then B, write the stoichiometric equation. Okay? Yes? All right. So there are 3 types of double replacement reactions. The first kind is very simple, actually. It's just very, very much a salt plus a salt yields a salt plus a salt. Now, there are reasons that chemicals react with each other. It has to do with things like entropy, which is disorder. An equation will only proceed forward if one of 2 driving forces are satisfied. The first driving force is increased disorder. So you want to increase disorder, and that's called entropy. And the other one is enthalpy. That's not important right now, but I'm just trying to tell you, I'm just trying to make a point. The other driving force is enthalpy, reduction of energy, internal energies. Okay? So it's going to do one of the other. It's going to either go because of increased disorder or lowering energy, or both. For instance, wood burns quite vigorously, doesn't it? Well, that's because you're reducing the energy of the wood. And that energy is going out in flames. So there's a lot of energy being given off, correct? And you're going from this nice, neat, organized wood, very organized, life is very organized, to ash and gas and carbon dioxide and water and all these many different things that are being produced. That indicates to anyone that disorder is obviously increasing. So that's one reason that burning wood, combustion of wood, is so vigorous, because both driving forces are considered. You are increasing the disorder of the products, and you are lowering the energy. So the products are lower energy and higher disorder. But in this unit, we are going to consider that all the reactions will proceed, and later on we'll predict whether or not they proceed based on other issues. But this is just an exercise in nomenclature and making formulas and writing equations, and that's what this point of the unit is. Okay? So we're going to give you an example that we've already done, actually, for stoichiometry, right? So one of them that we did was, if we have lead 2 nitrate. Salt has a positive and a negative component. That's a salt, right? Not sodium chloride is not the only salt. Okay, many people are surprised by that. Okay? And you add to it sodium iodide. Okay, and I want you to A, predict the products, and B, I want you to what? I want you to write the stoichiometric equation. So this is going to be A, B, remember we did this? A, B, C, D, yes? And you're going to combine the A here with the D here. You're going to exchange positive and negative components. You're going to displace one for the other. And then you're going to combine C with B. So it's going to be A, B, C, D yields, okay? A, B plus C, D yields AD plus C, B. Make sense? You're simply exchanging the positive and negative components. Clear? Yes? So the first thing you're going to do is, the first answer is, you're going to say, okay, this is going to be lead to iodide. Lead to iodide. Right? Lead to iodide plus what? Sodium nitrate, right? Easy? That's easy. That's all it is. Sodium nitrate. Now, that's it. Now, the rest of the problem is simply a question of nomenclature. So if you want to do this unit successfully, your nomenclature can't be okay. It has to be perfect. To do calculus, your algebra has to be perfect, not just okay. To do equation writing, your nomenclature has to be perfect, not just okay. You won't succeed, okay? And I've done many videos on nomenclature. They're all on T. Dorsey Chemistry. That's the YouTube channel, okay? Now, so the stoichiometric equation would be a matter of stoichiometry, which we've already done, plus notice how I am writing the formulas independent of the products and reactants. I'm just saying that is that, that is that. Got it so far? This lead to iodide is this. And this sodium nitrate is this. That's it. Now you have to balance it. Now, this kind of problem, you're simply going to balance the what? The units, the A's, B's, C's, and D's. In other words, the polyatomic ion remains intact, so you don't have to balance the individual components, the atom, the oxygens, the nitrogens, etc. I don't really teach you how to do that anyway. If you guys are smart enough, does this make sense to you? If you guys are smart enough to do kinetics and thermodynamics and stoichiometry, you're bright enough to do accounting, where the left equals the right? Yes? Makes sense? And I'll show you how you know the left equals the right. I'll show you how you know that. It's very simple to make sure it's correct. Okay? It's not just the left, the number of atoms on the left equal the number of atoms on the right. It's not just that. There's one more step that you have to make sure to check your work. Okay? So it's going to be 2 and 2. I balanced the nitrate. That was my. So I have 2 nitrates there, put it here, 2 sodiums, and you're done. Yeah? Now, how do you check it? Well, this is 1, that's a 1, to 1 to 2. 1 to 2 to 1 to 2. Isn't that lowest ratio? Can I get any lower? And whole numbers? No. So that you know it's correct. If you balanced it atom by atom and you wound up with 2, 4, 2, 4, would that be correct? No, because it's the lowest ratio. Yes, it would be balanced, but technically in chemistry, when we balance equations, it's the least combination, the lowest ratio. Okay? So that's the first kind. Okay? That's the first kind. Right? So this is A, this is the answer to A, and that's the answer to B. Okay? Every problem in equation writing will be in two parts. Predict the products, the names, and then write the stoichiometric equation. This is the names of the products, and this is the stoichiometric equation. Very good. Okay?
How do you spell that?
Stoichiometric.
Yeah.
Yeah, they say that in French. I mean, are you familiar with this in French? Usually a lot of things that are incomprehensible is usually French. I mean, I really mean that. I mean that in a. You never heard of it? Latin or? No, nothing?
First time.
You ever heard it? Yeah? Okay. You ever hear stoichiometry, Spanish? No? Maybe it's just some alien tongue, it's proof of alien life,
So it's German?
That's what they think of Basques, the Basque language is they don't know where it came from, maybe it's aliens, I don't think ETA would like that though, would they? Oof. Sorry, I'm just kidding, my Basque brethren, okay, all right, okay, all right, now, I had a furniture guy came over to fix our couch when I was a kid, and my mother said, "Oh, my son wants to go to Spain." You know what the guy said? He's from Basque. You know what he said? "Don't go there. We don't want you." Whoa, very upsetting. Okay, Basque, beautiful place, beautiful. Bilbao, right? What else? Bilbao.
Vitoria.
What is it?
Vitoria.
Oh, Vitoria. Yeah, very beautiful, very beautiful. Okay, so what's next? Did we do the sodium carbonate plus the hydrochloric acid? Did we do that example in here? Okay, here's one for you. You ready? A salt plus an acid yields a salt plus an acid. Let me explain. Okay? It's actually the salt of a weak acid.
Yeah.
For instance, we did that right?
Yeah.
Yeah,
Yes.
we did. No, we did the salt. Wait,
I'm just going to write it out. Okay?
the salt,
I'm gonna-
weak acid, and
Yeah.
a strong acid.
Yeah, I'm gonna. You know what I'm gonna do now? Now for everything I do, I'm just gonna write out the stoichiometric equation and explain it via the stoichiometric equation, because this really is a question of nomenclature. Yes, predicting products and nomenclature. That's all you have to be able to do. It's not a big deal. It's that. So just make sure that you understand that you want to limit yourself to what is it I'm expecting of you. Okay? Get it? Okay? So we have sodium carbonate plus what?
Plus 2HCl.
What is it?
Yeah.
2H.
2H. Yeah.
2HCl, right? So this is the salt of a weak acid, right? And this is a strong acid, right?
Yes.
All right? Yes?
Does any have a 2 on the bottom or no?
Yeah.
Yes, a 2 right here. Very good. Excellent, Fabiana. Very good. Excellent. Venezuela. Excellent. Got 2 points for the Venezuelan team. Okay. Right. Every country has problems. Venezuela has problems. We won't discuss problems in Venezuela now. I'll start an international incident, right? Tough. The United States has problems. We all have problems. Okay. So, what else? Canada, I don't think has any problems, do they? Yeah, I think that's the only country in the world that has no problems. I mean, the only problem Canadians have is it's really cold.
Yeah.
Is that like
That's the
the?
reason.
Is that exactly? There's no problems. It's a very cool place. Do you realize Canada? If they had the same problems of Spain, it would be 20 degrees warmer. Everyone would move there. So they have no problems. It keeps people out because of the cold environment. I think Canada Have you heard that before? Canada has like no problems? I think that's true. Every country has problems. Spain, Venezuela. I don't really care where you're from. I'm kidding. Yeah. Turkey? Where?
Egypt.
Oh, Egypt. Egypt. Okay. Okay, listen to CNN tonight. Okay, we have the United States over here. We have South Africa. Better. Canada. Okay. We have Enzo who can't make up his mind. He's from England and France. Okay. What are you? Oh! We try to deny that he's actually in this class. Abu Dhabi. That's how people from Australia say Abu Dhabi. They say Abu Dhabi. Okay. Like the movie Crocodile Dundee. That's not a knife. There's a knife got in Abu Dhabi. Okay. We have. Where are you from? Yeah. Where?
Algeria and Canada.
Algeria? How'd you say it?
Algeria.
Algeria?
Algeria.
Algeria. I like that. Algeria. Okay. Excellent. Those people who they don't pronounce it correctly where they don't really want to be known where they're from. It's a trick. Okay. So let's do this now. So it's just going to be a salt plus an acid is a salt plus an acid. In other words, the salt of a weak acid. This is a salt of a weak acid. I'll explain in a minute. This is a strong acid, hydrochloric acid. Muriatic acid, use it in concrete, getting rid of excess concrete when you do concrete work, yields sodium chloride, the salt of a strong acid, okay, plus the weak acid.
Yeah.
So you're going to get H2CO3. So you're going to have the salt of a weak acid plus a strong acid equals the salt of the strong acid plus the weak acid. Now, you got to, just give me a second, you got to balance it like that, right? Yes? Is that what you're going to say?
Yeah.
Way ahead of you, girl. Okay, so now, this isn't complete because, we did this, right?
Yeah.
Because the weak acid is going to decompose. Now, the weak acid is going to decompose, and this is an actual decomposition reaction that we'll go into in a minute, is plus yield CO2 plus what? Plus water.
Yeah.
Okay, can you see that on there? Can you see that? Is that clear? Okay. Now look at this. One carbonic acid, right? One carbonic acid. So one carbonic acid. So I can literally take this and replace it, right?
Yeah.
So now I have so listen carefully. You ready? This is the complete problem. You ready? Salt of a weak acid. All right? Salt of a weak acid. A weak acid oftentimes is a ternary acid. Oftentimes, ternary acid that we've done, yeah. Salt of a weak acid plus a strong acid yields the salt of the strong acid plus an acid anhydride plus water. What's an acid anhydride? An acid anhydride is a non-metal oxide. I will tell you all of the combinations. All of the polyatomic ion and what the corresponding acid anhydride is. Carbonate becomes carbon dioxide always, okay? Sulfur trioxide becomes sulfate. Sulfur dioxide becomes sulfite, etc. I'll give you those, not to worry. Understood? Yes? So that is going to be the second type of double displacement. Are you with me, Pablo?
Yeah.
Yes. Yes, Enzo.
There's a notification on the video.
There's another what?
On
your iPad.
On your iPad.
There's another what?
A notification.
There's
Low
a
battery.
I have a notification. Low battery. Okay.
Very first.
Low battery. Okay. I hope.